All right, so I'm David Martin from the Leadership Computing Facility. My day job is managing the Industrial Relations Program, but I'm going to talk to you about some of the computing at ALCF and Argonne in general. A lot of this applies to user facilities both at Argonne National Lab and at Oak Ridge. Is Susie Tishner here? There she is. Oh, good. So a lot of this, if you're interested in working with this in the DOE complex, Susie is a great one to talk to as well. And so a lot of this is kind of the same information. Let's see. There we go. So I always like to start with this. If you were with us last night, you heard Laurel Briggs talk about the history of Argonne. And the history of Argonne in nuclear engineering is really also the history of computing. So pretty much right away we realized that you couldn't do all of the calculations, all the data analysis for the nuclear engineering that was being done in Argonne by hand. So we developed computers, and so you see right there one that was built by the physics division here at Argonne. The picture there in the middle is of Jean Hall, which was the first computer scientist at Argonne, and before she was a computer scientist, she was a computer. So we had rooms full of people that were computers that did the calculations either by hand or using adding machines. And so she knew the algorithms. So you went from being a computer to a computer scientist here. These are kind of all the strategic priorities, and I won't go into these in great depth. You heard, if you were last night, Paul Kearns, our director, talk about the priorities. The thing I always like to point out, advanced computing is one of our priorities, but if you look across all the other priorities at Argonne, they're really based on computing as well. So if you're doing X-ray science or high energy physics or materials or manufacturing or anything to do with the universe, you're using computing either to do predictions and simulation or data analysis and machine learning on the other end to understand it. And so computing is a good place to be at Argonne, and I think a good place to be in the community. So Argonne has these big things called user facilities that the Department of Energy funds at different national laboratories. Argonne happens to have 5 of them. They're multi-million dollar, in a lot of cases close to $1 billion facilities that can't be really done by any other entity. Even large businesses can't build things like this. And so you see the list of them. But all of them have the same characteristics that ALCF does. They're open to everyone. There's no restrictions on organization or funding or nationality or research area. They're intended to do the best science available, and so that's what we do at ALCF. There is no charge for open science, though Susie Tishner will correct me and say the charge is open science, and so you have to publish. There are ways to do cost recovery, but we kind of discourage those. People often find ways to publish significant results out of the work that's being done here. All of the access is controlled by peer review, and so we have things that look very much like paper peer review, though they decide how much time and how much support you get. And then you always get expert support to go with it because these machines are fiendishly hard to use. So ALCF has 3 kind of focuses. One is leadership computing, so we always try to keep machines toward the top of the top 500. We're always working on keeping the machines running and going, so that is our leadership computing part. But the other 2 things that we do that are just as important, if not more, are the expert support. So about 1/3 of the funding of staff for ALCF goes to computational scientists and performance engineers and visualization specialists and all that know how to take the data, take the programs and make them really run on these very large systems, parallelization and data optimization and things like that. And then we're always working on the next generation machine. So I'll get to the next generation machine, Aurora, but we're even thinking about the next generation after that. Our user community, this is our pie of science. It's a little outdated, but it represents pretty much what we're still doing. We have people from all kinds of different domains using ALCF. So I'll go in there. So these are our big systems. Mira is an IBM Blue Gene Q system that we've had around for a while, and Cetus and Vesta are development systems that are smaller versions where people can try out things and do smaller jobs. Mira is going away at the end of the year, so we're in kind of the final stages of it. There will be a tear shed by many people at ALCF to see it go. It's rock solid and still running well, but we need the space for new things. Cooley is a visualization system that is attached to the same file system and networking as Mira, and so it allows people to do either in situ visualization or rapidly doing visualization after the data is produced. Our flagship system is Theta. That will be our big system going forward, which is a Intel Cray system that uses the Knights Landing or Xeon Phi processors, and that runs at about 12 petaflops. But you know, in addition to that, we have lots of storage and tape and networking and all that supports everything. But I wanted to, you know, communicate to people, since I'm kind of giving a HPC at Argonne, not just ALCF, that there's a lot of other HPC going on at Argonne. And so there are divisional clusters, there's a transportation research center computer, and there's what we call LCRC, our Laboratory Computing Resource Center. LCRC is a pretty big machine in its own right. It's around a petaflop and a half. It uses a combination of the KNL nodes and then some just normal Broadwell. And that's available to Argonne researchers, but it's also available to their collaborators. So we have a lot of people who come to Argonne and do really significant work in HPC who never touch ALCF machines. They're able to run in a somewhat smaller environment, but still significant problems. All right, so that's where we are now. This is where we're going, Aurora. You see a little timeline down there. We'll often refer to Aurora as A21 to keep us focused on the fact that we're determined to deploy this in 2021, which seems a long ways away, but you know, if you're doing this stuff, it's not very far. We are working a lot on doing the hardware and software specifically for that in conjunction with the exascale computing project. These are some kind of, there's a lot that's still under non-disclosure agreement with Intel and Cray about what we're going, but the curtain is opening a bit, and so I tried to put together a few of the things that are fairly significant about it. One that doesn't get a whole lot of press, but we're really looking forward to, is the new I/O system. And so we'll support, oops, I went back for another, there, okay. So we're going to support normal file I/O, of course, and it'll look like a normal file system that people can use. But we're also supporting the DAOS, the distributed asynchronous object store. And doing an object store gives us a lot of capabilities that aren't typically available in a large HPC environment. And so we're really looking forward to using that to optimize I/O, because as pretty much everybody in HPC knows, the capabilities of computing are increasing dramatically, but the I/O is not as much. And so being able to do object-oriented I/O, I think, will improve a lot of different applications. It will be a hybrid CPU-GPU, which is a first for Argonne as one of our flagships. There'll be multiple GPUs based around the XE architecture. We're using the Cray Slingshot interconnect, and we'll use a lot of programming techniques that are built around the one API that Intel is promoting now. And the last one down there, and I'm sure when Rick comes up he'll talk a lot more about this, but Aurora is intended to be a good machine for not only our traditional simulation, but data analysis, and also the new and emerging AI data science and learning things. Oops, wrong direction. Let's do that. So that's just kind of that I stole from Catherine Riley, our Director of Science, a little thing about how we see simulation and machine learning and data analysis all interconnecting. We don't really see them as three separate applications. We really think that you'll use data analysis to understand your data, but then simulation to compare it to expected ideals, machine learning to optimize things, and then we still do visualization a lot, and that'll still be an important thing. We'll be doing visualization both on Cooley and within Aurora as a visualization resource. So people always ask about programming, and this is the one slide that'll just kind of give you a taste of where we're thinking. We are encouraging everybody to think of MPI as the interconnect between the different nodes, so MPI plus X, and you get to define your own X. There are a lot of different options. I wish there was one that everybody agreed on. There's not a whole lot. I had another slide from Catherine that I didn't use that called it a zoo at the moment. Though there are a lot of things that are coalescing around some of the standards, and so SYCL and OpenMP and OpenCL I think are the ways to go with MPI. to use for on-node communication. We're focusing on C and C++ first, but there's certainly support for Fortran. We're going to support all the different AI frameworks that I'm sure Rick will talk about, and then I mentioned already the data, traditional and object-oriented. All right, so how do you get access to these things? We have 3 major allocation programs, Insight, ALCC, and the Director's Discretionary, and Oak Ridge does a very similar system. The first 2 that give out about 80% of our resources are done every year. So if you look, there's the one just closed in June for the Insight. ALCC usually closes in February or so. And those are pretty large awards. And so, you know, it's a few million node hours. We used to talk about core hours, but we're going to node hours now. So if you multiply by 64 for theta, you get core hours. It's a lot of time, and we tend to do these really large projects. And then in the Director's Discretionary, it allows us to do a few smaller projects, and a lot of times where industry starts out. I wanted to talk just really briefly about our plans for how to prepare for Aurora. And so we have something called the Early Science Program. And we have 5 projects in each of our kind of focus areas: simulation, data science, and learning. And those are really intended to be people working now. They've all been chosen, and they're all working toward exascale. And so we hope that they'll have capabilities day 1. But there are other ways to engage. So I've talked about ALCC and Insight and the Director's Discretionary Early Science. There's also an Argonne Data Science program, which has a yearly call that gives you time and expert support specifically around data science, because we realize that's a critical need for a lot of scientists who maybe don't have the level of expertise they need. There is the Exascale Computing Project, which Doug Cothe will talk a lot about later today, but ALCF is very engaged in that, and that is a way to engage with ALCF. So if you're part of an ECP project, you can get time at ALCF, expert help. There is a continuing integration environment that we're supporting to support ECP, and so that's a way to get in. And then there's a program that the Department of Energy runs that gives you access to expertise and time at a bunch of the different national labs. It's called HPC for Energy Innovations, and they have pillars in manufacturing, materials, and mobility. And that gives you both some funding that goes to the laboratory to help you out, and also computing time. And those are both available about on a twice-a-year call, and it's specifically to industry and government entities that are wanting to work with the lab. And then we have lots of things around CRADAs, cooperative research and development agreements, and strategic partnership programs, and proprietary. But the one that probably is the most frequent, and we don't really address it much, is these informal collaborations. And so we encourage people to just informally collaborate with people. Oh, wrong direction. There we go. So I won't hit this again. Valerie did a great job in talking about all the different divisions at Argonne. But ALCF is a production facility, but we have all these research facilities that work with us and help us understand where things are going and solve really knotty problems. So what I want to mention at the bottom there is the Joint Laboratory for System Evaluation. So we have a joint between the MCS and the all the computing areas at Argonne and ALCF to run kind of a test suite of things, and so we're always trying out new hardware. Okay, so the last thing I wanted to say is some of our growth areas. So we have something called ABLE, which is our biomedical learning environment. It's I had to write this down to remember, NIST 800-53 qualified system, which allows us to do things around health data that we can't in a normal environment like ALCF. We're heading toward HIPAA and FSMA compliance, so that'll allow us to work on data that is personally identifiable to people and do a lot of things around genomics and around any health data, and I'm sure Rick will talk about that. Quantum computing is a big effort here, not just around the basics of quantum computing, but around architectures and the infrastructures required and software and algorithms. Even if you handed somebody a quantum computer today that was working well, the idea of interfacing it to a traditional computer and getting good production out of it is really a challenge. And so we want to work on all that. It's very much a research project. You can't come to ALCF and get a 80-qubit quantum computer that you can try out on your own. But we are really working on the algorithms and how to make these things work. And so if you're interested in that, be sure to talk to us as well. The last one is AI for science, and I will not steal Rick's thunder, so I think that's the end of my talk here. Good. Thanks.